Hello everyone, in this video we are going to discuss about chemical engineering GATE 2018 fluid mechanics questions with solution. GATE 2018 question paper and answer key link is available in my description box. You can download it. Question number 38. At a shear rate of 10 second power minus 1, the apparent viscosity of a non-Newtonian liquid was found to be 1 Pascal second. At a shear rate of 100 second power minus 1, the apparent viscosity of the same liquid, that is same non-Newtonian liquid, was found to be 0.5 Pascal second. If the liquid follows power law behavior, the apparent viscosity in Pascal second at a shear stress of 10 Newton per meter square or 10 Newton meter power minus 2 is dash. This is the question. So what is apparent viscosity? In fluid mechanics, apparent viscosity is the shear stress applied to a fluid divided by the shear rate. So apparent viscosity is denoted as neta. For a Newtonian fluid, apparent viscosity neta is constant. So this is equal to the Newton's law of viscosity or Newton viscosity of the fluid. But for non-Newtonian fluid, the apparent viscosity, that is neta, depends on the shear rate. Shear rate is denoted as du by dy. So here the apparent viscosity depends upon the shear rate. Apparent viscosity unit is Pascals again, but the centipoise is denoted as Cp. So centipoise is frequently used in practice. Okay. So here the shear rate du by dy 10 second power minus 1. The apparent viscosity that is neta or mu naught. Mu naught also denoted as apparent viscosity. So this is equal to 1 Pascal second. So shear rate, that is du by dy 100 second power minus 1, the apparent viscosity neta or mu naught, that value is equal to 0.5 Pascal second. If the liquid follows power law behavior mean the power law is the simplest model that approximate the behavior of a non-Newtonian fluid. So the limitation of this law, its limitation are that it is valid over only a limited range of shear rate, that is du by dy. So the value of flow consistency index, that is K, and flow behavior index N are depends on the range of shear rate, that is du by dy. So generally, so the power law is the simplest model that approximate the behavior of non-Newtonian fluid. So if the liquid follows power law behavior, the apparent viscosity, that is neta or mu naught, so we are going to determine at a shear stress of 10 Newton per meter square. Shear stress is denoted as tau. Okay. So here du by dy is equal to 10 second power minus 1. Mu naught is equal to 1 Pascal second. So when du by dy is equal to 100 second power minus 1, so mu naught or neta is equal to 0.5 Pascal second. If the liquid follows power law behavior, to determine the neta or mu naught, so tau value 10 Newton per meter square. After calculating the apparent viscosity value, we have to round off the result to 2 decimal place. Data. So already I said this is power law behavior, non-Newtonian fluid. So shear rate du by dy 10 second power minus 1. Apparent viscosity is denoted as neta or mu naught. So the mu naught is equal to 1 Pascal second. So when shear rate 100 second power minus 1, apparent viscosity mu naught or neta 0.5 Pascal second. So already I said the fluid follows the power law behavior. Power law behavior, the power law is the simplest model, the approximate non-Newtonian fluid. So here the apparent viscosity to determine. So when tau value is equal to 10 Newton per meter square. So tau is a shear stress. This is the data. So to find if the liquid follows power law behavior to determine the apparent viscosity when shear stress is 10 Newton per meter square. Solution. Power law for non-Newtonian fluid. So this is the power law equation. Tau is equal to K into du by dy power n minus 1 du by dy. So here tau is a shear stress. K is a flow consistency index. So here du by dy, that is a shear rate. What is the n here? N is the flow behavior index. So the n is the flow behavior index. So here tau is equal to mu naught into du by dy. What is the mu naught here? Mu naught is the apparent viscosity. So the apparent viscosity here, the apparent viscosity from this equation. So mu naught is equal to K into du by dy power n minus 1. Okay, that is the mu naught or apparent viscosity. This is the equation number 1. Equation number 2, this is a given data. Shear rate 10 second power minus 1. Apparent viscosity 1. When shear rate 100 second power minus 1. Apparent viscosity 0.5. This is the second equation. So the what is the mu naught from the previous expression? Mu naught is equal to K into du by dy power n minus 1. This is the apparent viscosity equation, equation number 3. So substitute equation 2 in 3. So we have two different shear rate value. So the substitute in equation 3. So after substituting the shear rate value, so we have the two expression is right. One is the fourth expression, another one is the fifth expression. So the when du by dy is equal to 10, mu naught value is equal to 1. When du by dy is equal to 100, mu naught value is equal to 0.5. Okay. So this is the equation number 4 and 5. So divide equation 4 and 5. So fourth equation, that is 1 is equal to K into 10 power n minus 1. Fifth expression 0.5 is equal to K into 100 power n minus 1. Divide these two expressions. So the finally we get left hand side, this is the numerical term 2. Right hand side, KKs are cancelled. There is flow consistency index. So only we have flow behavior index, that is n. So after reducing this expression to determine the flow behavior index, that is n value. Okay. So here 10 by 100, that is equal to 1 by 10 power n minus 1. Here left hand side is the same, 2 is equal to, here 1 by 10, that is 0.1 power n minus 1. Here power n minus 1 na. So here 0.1 power n, 0.1 power minus 1. Okay. So here 0.1 power minus 1, that is equal to 10. So here this 10 comes to left hand side, 2 by 10. 2 by 10 is equal to 0.2. Right hand side we have 0.1 power n. Okay. So both side take log value. So here log of 0.2 is equal to log of 0.1 power n. Already we know the formula. This is log a power x is equal to x log a. Okay, so this is the formula. Apply this formula here, x log a. Okay, so this is the formula. So here apply our expression log of 0.1 power n. So here x is a n, log of a is a 0.1. Okay, so n log power 0.1. So left hand side log of 0.2, 0.6989. Right hand side n into log of 0.1 minus 1. So finally we get flow behavior index n value 0.6989. Okay, so after calculating the flow behavior index, this value substitute in equation 4. Already we have the two expression is right, the fourth and fifth expression. You take any one expression, substitute the flow behavior index n value to determine the flow consistency index, that is k. Okay, so here the fourth expression 1 is equal to k into 10 power n minus 1. So here n is a 0.6989, substitute here. Find out the flow consistency index, k is equal to 2. Okay, so now we have flow behavior index n, flow consistency index, that is k. Okay, so we know the flow power law, that is tau is equal to k into du by dy power n. So here if the liquid follows power law behavior to determine the apparent viscosity when shear stress is equal to 10 Newton per meter square. So shear stress values are 10 Newton per meter square. K and n values are calculated value to determine the shear rate value. Okay, at this condition determine the shear rate. So shear rate means that is du by dy. So after substituting this value, finally we get du by dy is equal to 9.98. Okay, so now we have shear rate value for this condition. So again we take apparent viscosity formula. Apparent viscosity mu naught is equal to k into du by dy power n minus 1. So here we want apparent viscosity, flow consistency index k values are known, shear rate du by dy is are known, this is calculated value. N is a flow behavior index, that is also calculated value, substitute here. Finally we get for this condition apparent viscosity is equal to 1. Okay, the liquid follows power law behavior to determine the apparent viscosity when shear stress is equal to 10 Newton per meter square. That is the question is right. Finally we get apparent viscosity is equal to 1. This is the unit Pascal second. Okay, this is a unit of apparent viscosity in this problem, Pascal second. Okay, this is the answer for this problem. Answer range is 0.98 to 1.02. Okay, this is the answer range for this problem. Okay, for further related videos you can like, share and subscribe my channel. Thank you.